this video, we will demonstrate how you can schedule and orchestrate workflows for multiple systems using SAP Data Hub. Here we are at the Data Hub Launchpad. Before building a workflow, we must create connections to any of the source systems we wish to use. Once that is done, we can open up the modeler to create a new workflow. In our operator list, we see the set of data workflow operators. These are the ones we are going to be working with. All workflows must begin with a workflow trigger, which will drop onto our graph now. Next, because we are going to orchestrate the execution of processes from two different systems, we're going to add a workflow split operator. The split operator simply enables us to create multiple parallel execution paths for the workflow and is useful when executing independent processes inside of a workflow. Data Hub allows us to remotely execute a variety of workloads in the set of supported systems, including SDI flow graphs, BW process chains, data services jobs, and even other data pipelines that we've created inside of Data Hub. In this case, we're going to add a BW process chain to our graph. We choose a connection from the configuration, which again was created earlier in the connection manager. Then we either type in the name of the process chain we wish to execute, or we can select a process chain from the drop-down that shows us the available process chains on that BW system. When executed, this operator will connect to the BW system, execute the process chain, and return once it has completed. Next, we're going to add a data pipeline graph to our workflow. Again, in the configuration for the operator, we're going to choose the graph we wish to execute inside of Data Hub. This is a data processing graph that we previously created in the modeler, and we can see its definition here. It uses the text analysis engine to do a sentiment analysis of a set of product reviews stored in HDFS. Again, when this operator is executed, it will make a call into Data Hub, telling it to run the specified data pipeline graph, returning when the graph has completed. We could use multiple workflow split operators to execute other remote tasks, but in this case, 2 is enough to illustrate the process. Now that our 2 processes have been configured to execute, we need to coordinate and take some action when they are finished. This is where the workflow merge operators come in. There are 2 types of merge operators: the OR operator, which will wait for either of the previous operations to finish before continuing, and the AND operator, which will wait until both processes are completed before proceeding. In this case, we are going to use the AND operator. This will make sure we are sure both processes have completed before we go on to the next step, which is to merge our results into the final data set. To merge our results, we're going to add a data transform operator to our graph. The data transform operator is configured like a mini pipeline. To access the definition, we can double-click on the operator, or from the configuration menu, we can click on the definition. Once we open the data transfer subgraph, we have a new blank canvas on which to create our transformation. Note that there are a different set of operators available to us for defining the data transform. A data transform typically consists of 1 or more data sources, a transform operation, and a data target to write the results of the transform. In this case, we're going to add 2 data sources, 1 for each of the outputs of the workflow operations we executed. The first source is going to represent the output of the BW process chain, which was written into a Vora table. So in this case, we're going to choose a Vora connection and schema and table name where we know the data was written. Note that the UI automatically populates the definition for the table schema, and if we want, we can also preview data in the table, although in this case there isn't it yet. So once we finish configuring this first data source, we can go back and configure our second data source. It is going to be the result of the data pipeline execution, the sentiment analysis, and it's also stored in a Vora table. So again, we'll choose the Vora schema and table, which contains the results, and we can see this as before, the schema is populated So now that our data sources are defined, we can perform our transformation. You can see the available transforms in the list of operators here. We are going to join the two data sources together in this case, so we're going to use the join operator. Once we have connected the graph, we can open the join operator and define the join condition and output columns. Double-clicking on the operator opens up the join definition. In this case, we're going to join on product ID, so I'll click on product ID and just drag and connect them together. This will pop open the join definition dialog and give us our proposed condition, which is an inner join. We're free to change this if we wish to the various joins supported. We also have a SQL helper available that allows you to look up any columns or reference names if you want to build a more complex join operation. In this case, we're going to just accept the inner join, and now we're going to specify the set of columns we wish to include in the output. So we're going to include product ID, we're going to include country, region, the sentiment from the sentiment analysis, and the number of occurrences of a specific sentiment. That completes the creation of our join, so we can return back to our data transform. Now that it's complete, we can write the result of our join into another Vora table. To do this, we're going to add a data target and connect it into the graph. Again, we're going to choose the Vora connection, and we're going to choose the table in which we want to write our results, which is called sentiment analysis. When we choose a table from Vora, it will pre-populate the output columns with the set of columns from that table, and it gives us a mapping here. So we can choose column by column from the output of the join which columns will map to the table in Vora, or we can do an auto propose, or we can simply use auto map by name. So this will map the names of the column from the join to the names of the columns in the table. So we can see here everything matches up except for one. And in this case, because there's a different spelling between num occurrences in the table and num occurrences in the join, we have to manually specify that one. So we'll simply choose num occurrences, and then we'll get rid of the extraneous value at the end. Once we're happy with our data target, we can return back to our data transform, review it, make sure it's everything we need, and now we can return back to our workflow. This is the last operator in our workflow, but in order to actually end a data workflow, you need to add a workflow terminator operator. So now we'll add our workflow terminator, which indicates the end of the workflow. So now we've seen that we've taken from our workflow trigger, executed a BW process chain, a Vora pipeline. When both have completed execution, we take the results of both, combine them together into a Vora table, and then we end the workflow. Now our workflow is completed and ready to run. So we'll save it and execute it. We can see the execution status down here. And while that's happening, we can also easily create a schedule for this workflow by opening the schedule dialog, picking a name, and then filling in the form specifying the proper time. So for us, let's set this workflow to execute at 12:30 and then hit schedule. And we'll see our schedule graph pop up here. We can also see our running workflow has executed the sentiment analysis graph while it runs, and we're also able to switch over to our monitor. And if we refresh our monitor, we can see the instances of our graphs that are running. While we wait for the workflow to complete, we can also look at subgraphs here, which shows us all of the graphs that are instantiated during the workflow execution. So workflow runs. Here it's executing the Data Hub subgraph to do the sentiment analysis. Here it's executing the BW process chain. This is a graph that's executed as part of the vFlow pipeline. And when that graph finishes, we then have our data transform operator which executes, and when that finishes, our graph completes. So now that our graph is complete, we can go into the VOR tools and check the data in the table. We see that we have our product ID, country, region, sentiment, and number of occurrences all configured. That concludes this demo, which has shown you how to orchestrate the execution of remote processes from within Data Hub. Thank you.